to my video. I am Ananth, working as an assistant professor of physics in Bishop Weber College. I am going to discuss about Geiger-Muller counter.
As we know that several high energy particles like alpha ray, beta ray, gamma ray and proton, electron are emitted during nuclear reactions. To understand these particles and their interactions with atomic nuclei, we should know about their properties like mass, momentum, energy. So for that purpose, we employ some techniques for the detection of these particles and for analyzing their energies. Some of the techniques are ionization chambers, proportional counters, GM counters, solid state detectors, and cloud chambers, in which Geiger-Muller counter or GM counter is one of the important nuclear radiation detector. This GM counter was designed by Geiger and Muller in 1928, and it works based on the process of ionization. Get into the function of a GM counter, let us discuss the construction of a GM counter. The main part of this counter is metal chamber. It contains 90% of inert gas like argon and 10% of ethanol. Here it acts as a cathode. A tungsten wire is stretched along the axis of the Geiger tube, and it is insulated from the metal chamber by ebonite plugs. Here, this tungsten wire acts as a anode. So, the tungsten wire is connected to the positive terminal of the high tension battery through a resistor, and the negative terminal of the battery is connected to the metal chamber. In this circuit, we have to apply less voltage to avoid discharge between the electrodes. Electronic counter is also associated with this setup, which is capable of measuring the current pulse happens due to the potential drop across the resistor. Now let us discuss how this GM counter detects the nuclear radiations. For example, the external radiations like alpha rays enters into the chamber, it collides with the gas molecules. Due to these collisions, the outermost electron of the gas molecule absorbs the energy of alpha rays and become a free electron. That leads to the creation of positive ion and free electron. We call this effect as ionization, and it is due to the external radiation. As a result of ionization process, we get the positive ion and free electron, and these are subjected to external electric field applied by high tension battery with the range of 1000 to 3000 volt. Due to the potential difference, the free electron move towards to the anode wire and the positive ion move towards to the metal chamber. If the applied potential is strong enough, the free electron accelerated with the high velocity and collides with nearest neighboring molecules and leads to the secondary ionizations, which produce more electrons and are called secondary electrons. Further, these secondary electrons are also get accelerated and collide with neighboring molecules and produce free electrons. This is like a chain reaction. It produces a more number of free electrons along the way to reach the anode wire. And this effect is called avalanche effect. And this is the main principle behind the function of Geiger-Muller counter. The positive ions are moving towards to the chamber while the free electrons are moving towards to the central wire that flows in the circuit make a potential drop across the resistor that leads to the small current pulse in the counter. And this is amplified by a electronic circuit and made to operate a counter. In this way, a single particle can be registered. These free electrons come back to the surface of the metal chamber, and already the positive ions are accumulated on the surface, and these free electrons recombined with the ions to create neutral molecules. Now there is no free electron and a positive ion in the chamber. So this whole process is due to the arrival of one alpha ray. So now it back to the Geiger-Muller counter setup is back to its original state, and it is ready to detect next particle. Here, I just show the process of detection again. Subsequently, we discuss some important factors involved in the GM counter. To study the voltage characteristics of a GM counter, we plot the counting rate against the counter potential. Here, we vary the potential from few hundreds to few thousands. If the potential is low, the tube does not work. If we increase the potentials above to the threshold value, the counting begins and rises rapidly to a flat portion of the curve called the plateau. And this is the region of the counter operation. So, if we further increase the applied electric field, a continuous discharge takes place in the tube. And without ionizations, the counting rate increases very rapidly. So, therefore, tube must not be used in this region. Now we know the process of detection that once the electron is created in the chamber due to the external radiations and it leads to the avalanche effect, and these electrons complete the circuit and recombine with the positive ions. To complete the whole process, counter takes a little bit of time, and during that process no external radiations can be detected by the counter. In this time, the detector is inefficient, and this time period is called as dead time. The process of recombining the free electrons with the positive ion to create a neutral atom might lead to creation of photons, and these photons may cause for another avalanche effect, and it makes error in the counting rate. So we have to remove these photons or excess energy in the chamber. So this photon or the excess energy are absorbed by the alcoholic compounds already present in the metal chamber. So this process is called as chemical quenching. So it avoids further delay in counting the nuclear radiation. So the GM counter has several advantages in nuclear radiation detection. So it is portable and serves best for mineral prospecting apart from its applications in cosmic ray work. So it also has some limitations. So it is insensitive for a period of 200 to 400 microseconds. So in this time it will not be able to detect external radiations. So further, it cannot provide informations about the particle or photon causing a pulse if they have a same energy.
Thanks for watching.